Anything else? Let's see who's more accurate, Cornejo or me. So we'll go up here to, what is that,
640.
Cornejo? Well, I know the height. What's the x value?
12.
Okay. So we got 12 comma 640. And what is the other location? 8 comma 3. What is it?
320.
320. Okay. So we would take what? 640
Minus 320.
minus the 320, or 12 minus 8.
Yeah.
What's 640 minus 320? 320? What's 12 minus 8? 4?
4.
You get 80. Huh?
It's 80. Yeah. And I said it was 80.
That is what they believe is an approximate to this thing. Now, if you take this point here, what do you believe this point is right here? Well, it looks like it's about what?
9, 10.
No, not 9.
Why?
Because this is already what? What's this location?
12.
12. So
So
it
10.
can't jump over here to just be 9.
10.
Yeah. Okay, so we'll call it 10 comma what? What's that location?
340.
What is it?
340. It's going up by 20s or
No,
what?
it's not.
Oh, by 160?
380.
No, it's not.
You have 400, headgummit.
Oops.
We'll go down to this little guy here. What does that look like? If this was 2 steps forward, we'll believe this is 2 steps backward. We'll call it 6. Is that right? So, oh, wait a second.
Should be a 1.
This is 1 step forward?
I mean, I think it should be 1 step.
What would we say this was, 12?
Yeah.
Yeah.
There's 3 lines.
Yeah. You want to do 1 here? Call it 7. 7 comma what? 240? You want to call it 7?
Sure.
Alright. So, 400 minus 240 over 10 minus 7, give me what? 160 over 3. What'd you get? 53.33333. Those are options. What were the options in the little slot here?
I think it was like 60, 80, 120, something else.
Really? I can't be that far off. Hold on a second. No, maybe it's 80 or 100, 120. That's certainly 240. And it's certainly, what do we call it? 400. That's certainly right. Tell me, it's that far off? I don't believe it.
Did you say the top one was 1 step forward, so 2 steps from 8?
Because you chose
If
2
that's-
points from the same
If that's
time.
1, then we would change that 10 from.
You're saying change this to a 9?
Yeah,
I hear.
that would make it 8.
Yeah, I hear. Flush that a little bit. Yeah, I hear. We call it 1. Yeah. Alright. Anything else? No? Loggers. So the rules continue. We will have 2 more sections of rules, and then on Monday it will be applications called related rates. But this day will finish up all the derivative techniques you will need for the rest of the course and the rest of your entire life, probably. Thank God.
Don't say that.
Yeah. Yeah. So what is it? 3, 8. 3, 8. Log and exponential. We'll start with the exponential. We talked about it already in short its derivative. but the log is highly related to it. So we'll start with the exponential and lead towards the logarithm. So every exponential function, b to the x, has a y-intercept of 1. Okay? Y-intercept of 1. You know, there's a y-intercept.
You said every b of x is a y-intercept?
B to the x. Any b to the x, 2 to the x, 5 to the x, half to the x, any positive real number that's not the number 1, even if it is 1, is going to have a y-intercept of 1. Okay? We're going to split this in two cases. There are exponentials where the base is greater than 1, and there are exponentials where the base is between 0 and 1. The difference is the function increasing or decreasing? The asymptote is the same. There's your two pictures. This one is increasing. This one is decreasing, always. They both have, since it's sheared material, they both have asymptotes at what?
Y equals 0.
Good, y equals 0. Any other wonderful features they have?
They
Well,
cross at 1.
say again.
They cross at 1.
Cross at 1. So we know that b of 0 equals 1. Right, there's our y-intercept for all these. Oops, want the dot there. Okay, there's our y-intercept. And what else? Over here, the limit, we talked about this a while back, as x goes to infinity, as the end behavior over here is the function, oops, b to the x goes to infinity, but as you go towards negative infinity, that's where the asymptote comes into play more so. So limit of b to x as x goes to negative infinity is going to be 0. That's an important thing to remember for later on in the class as well. And over here, it's somewhat reversed, correct? Limit of b of x when b is a proper fraction is what this wants to say. Don't forget the inequality so much. Just remember, here the base is a proper fraction. Okay. Then, as x goes towards infinity, now you're heading towards the asymptote. So that's going towards 0. And if you go towards negative infinity, with the x, then the function is growing without bound. Okay? Everybody okay so far? Standard exponential function.
Wait, explain the horizontal asymptote again.
They both have a horizontal asymptote at y equals 0. That is, the x-axis is the horizontal asymptote.
Okay.
And if the base is greater than 1, like 2 to the x, 5 to the x, e to the x,
Yeah.
then as you go to the left, that's what this is trying to say. As you go to the left, the function heads towards 0, but will never reach it. And as you go to the right, as you go to the right, it just keeps growing forever.
Okay.
And then it reverses over here. Over here, whenever you have a proper fraction for the base, like a half or a third, something like that, or 5/6 to the x, then as you go out to the right, it heads towards its asymptote, it heads towards 0.
Okay.
That's all. I'm just writing the notation for what the picture's trying to say.
I just couldn't see the limit part on the other thing. That's all.
Oh yeah, that's all. Okay.
Huh?
No x-intercepts.
Like all of my things.
These standard exponential functions. No x-intercepts.